Hi everybody, let's talk about Super Happy Funball. So the idea here is that you have a ball starting at a certain height. So we'll say this is up at a height, and in this case it happens to be 9 feet. So you have a ball at 9 feet and you're going to drop it, and the ball is going to travel down, and then it's going to rebound back up at a certain height, and then it'll travel down and rebound back up again at a certain height, and go down and again and again and again like this. And the idea is that every time it rebounds, it returns to a height that is 11/12 of the previous height. So our initial value, n sub 1, is going to be 9 feet. In this case, your numbers might be a little bit different. And the common ratio, how much you're multiplying each iteration, is going to be 11/12. So if we were to real quickly do sort of a brute force on this, you would say that n sub 1 is equal to 9. N sub 2 would be 9 times 11/12, which is 99/12, which becomes 33/4 of a foot. That's the height. And n sub 3 would be 11/12 of the previous version. So that's 33 over 4 times 11/12, or maybe another way we could write this would be 9 times 11/12 times 11/12, which is going to be 33/4 times 11/12, which is 363 divided by 48 feet. So in general, the formula we're going to have is n sub k equals the initial value times our common ratio, 11/12, to the k minus 1 power. And that will tell us the height that the ball rebounds after how many bounces. Now in part 1, the question asks, how many times will it bounce? Okay, how many times will it bounce, that is k, before the rebound is less than 1 foot? So this is our n sub k. The 1 foot is our height. And so what we're going to do to solve this first part is we're going to say 1 is, you could say greater than or equal to, if you wanted to. You don't really need, you could just put an equals in there anyway. But it's going to be a 9 times 11/12 to the k minus 1 power. That will solve this for k. That will tell you how many bounces it takes before that height is less than 1 foot. And that's what the first part is asking. How do you know when that height is less than 1 foot? So solve this equation, and that will give you the answer to part A. Now for part B, they're asking how far will the ball travel before it comes to rest on the ground. And when they say how far will it travel, they mean how far up and down will it travel? How many up downs will it travel vertically before it comes to rest? And so this is an infinite sum. We're going to figure out, well, and I guess what you could do is maybe it's not an infinite sum, but you would set this equal to 0, greater than or equal to 9 times 11/12, k minus 1, and you're going to solve this for k. And see what you get for k. That'll tell you how many bounces it takes before it actually comes to rest, before that value is 0. We could probably also write this maybe as an infinite sum, but either way, you're going to say s sub k, that's the total travel time, all of these added up. So this one plus this one plus this one plus this one, that's going to equal n sub 1 times 1 minus r to the k over 1 minus r. Now, I'm not quite sure what k is going to shake out to be here, but I imagine it's going to be a really big number. And so you're going to take that really big number and you're going to plug it in here. It might even be the case that this turns out to be infinity. And if that turns out to be infinity, then like we talked about in class, this whole thing goes away, because remember r is 11/12, and 11/12 to the infinity power is pretty close to 0. So this should shake out to be n sub 1 divided by 1 minus r. And that's how far the total distance this thing will travel should be. So hopefully this will help you solve the Super Happy Funball problem. Let me know if you have additional questions.